Rate of reaction, drawing graph, calculation, tangent. Let's go. Okay, welcome back to another episode of no, I'm doing a TV show, but welcome back to another video, right? So today I want to talk about your Form 5 Chapter 4.1, which is rate of reaction, calculation, drawing graph, and looking for tangent and whatnot. Okay, so first of all, the material is available for you to download in the description box below, and I need your calculator and I need your graph paper. Okay, so let's get right into it. Now, this part, nothing much to talk about, nothing much to teach in theory. It's just basically calculation and drawing graph. So we'll just talk about the formula and we'll get into some exercises. Yeah. So rate of reaction in the change in quantity of reactant or product per unit of time. So every chemical reaction that happens, no matter burning a metal that releases gas, or dissolving a metal into water and it releases gas, or any chemical reaction in your daily life, it will have a rate to it. Means you can calculate the rate of the reaction by dividing the time taken. So change in quantity, okay, of the reactant or product, okay, divide by total time. So reactant basically means before, product means after. So chemical reaction 之前的叫 reactant, reactant 出来过后的叫做 product. Okay, so that's the formula: change in quantity divide by time. So there's three types of calculation we can look into. Number one will be rate, or the normal one, rate of reaction. Number two will be average, means like everything. And the third one will be the challenging one to maybe some of y'all. It's called tangent, which is looking for a particular point of time, or we call instantaneous rate of reaction. Okay, right. Let's look into one of the very straightforward and simple examples here. 0.3 grams of magnesium tape react completely with excess dilute hydrochloric acid in 30 seconds. Okay, calculate the rate. So you have 0.3 grams, you have 30 seconds. All right, so putting to your formula, rate of reaction equals to change in the quantity, means before and after, change in quantity. 之前跟之后的分别叫做 change, the difference in between, okay, over the whole cost of time taken. So there you go, 0.3 minus 0 over 30 seconds. Calculator will do the job. GS negative 1. GS negative 1 when you divide, right? Okay, that's it. That's a very simple calculation, I guess. Maybe we will get straight into some exercises to try out. Now, usually in question, you don't really have to bother about what reaction is that. Doesn't matter. Actually, this topic just wanted you to focus on how to do the calculation, how to find the rate. Okay, everything happens with a rate. So if you read something that you're not too sure what is happening, never mind. You are just looking for the rate. For instance, Mikhail carried out an experiment and carbon dioxide gas released when collected. See, I don't even know what is Mikhail doing. It's just say that, oh, I do something and then I collect carbon dioxide gas. Okay, in interval of 30 seconds. So this is the time that I'm given. Yeah, 30 seconds. Right. So 0, no carbon dioxide. 30 seconds, we have 20.5. So another 30 seconds means 60, interval of 30 means we kept adding on. So these are the amount, yeah, given. So like question number 1, calculate the overall average rate of reaction. So we're looking for average rate of reaction. Overall. So we will look for the end of the reaction and then we'll calculate the whole thing. So first thing first, where the reaction stop actually. A lot of people are like, the last one lah. Well, if you take a closer look, right, the volume of carbon dioxide has been constant for 2 times already. That means at 150 seconds is where the reaction stopped. And then the gas is just in the container. If the time goes on, the gas will still be there. So if I go on with however many seconds, my amount will still be 45. You get it, right? So actually this is where I stop. This is the ending, not the last one. Be careful on this question. Okay, so like rate of reaction, I'm just going to use R as a symbol. So rate of reaction equals to change of the quantity divided by time. So for this case, I will just have to use the last one, which is 45 of the volume divided by the time. Okay, so if you want to calculate overall, then usually average out, then usually we don't need to minus it. We just take the last one. Yeah. So like, shall we? 45 cm cube in volume of gas, right? Yeah. Okay. Over 150 second. Okay. So calculator will do the job. Okay. Equals to 0.3 cm3s negative 1. Okay, cm3 negative 1 s negative 1. Okay, it's just like that. Very simple maths. Actually, not really difficult in maths. It's just you have to know what question is looking for. Next one, average rate of reaction at the first minute. You know what's first minute? First minute means 60 seconds. So we want to cover first minute, 60 seconds. Okay, yeah. So the first minute, never mind, formula first, rate of reaction equals to the change of quantity divided by time. Change of quantity, 60 minus 0. Actually, no need lah, but we do layan to show the formula lah. Okay, and then 31 minus 0 also. So on top is the change of quantity. So 31 minus 0 cm cube over 60 minus 0 second. Okay, layan saja. Okay, we show the working a bit. But actually same as 31 over 60, 0.516. 516 is say so 517 now we can round up 0.517 cm3s negative 1. Actually 2 decimal place also, 2 decimal also can, 3 also can. 3 also can, 3 is acceptable. Okay, so far so good. Yeah, right. And I think we get to the C next one. Average rate of reaction in the second minute. You know what's the meaning of second minute? Second minute means that I only want to focus on the whole second unit. Okay, so this is where I want to focus on, from the 60th to the 120th. 60 to 100, that means the second minute. Yeah, so I will use this to minus this. Change in quantity minus change in quantity divided by time. Yeah, okay, so there you go. Formula comes first. Yeah, 43 minus 31. 43 minus 31 cm3 over 120 minus 6. Okay, I mean we know, but just want to lion a bit. That will be in second. Okay, so right, calculator do the job. 0.2 cm3 s negative 1. Okay, can. Yeah, there you go. That's the second minute. Yeah, right. D, next one. Average rate of reaction in the first 2 minutes. That means I want to include the first minute and the second minute. Means I want total of first and second together. Okay, not the second minute only. If I want the second minute, means I don't want the first minute. I want the second, not the first one. Okay, but if I say I want the first 2 minutes, means I want the first minute and also the second minute together. Okay, so same rate of reaction equals to change in quantity over time. So change in quantity will be, the second minute is 43 minus 0. Actually, no need lah, we layan no need lah. 43 minus 0, that's the change. Second minute minus the starting, which is 0. Yeah. Cm3 over time. Time will be 120 minus 0 second. Okay. Calculator do the job, and that will be 0.358 cm3 as -1. Okay, there you go. So from here you can kind of know, like sometimes question wants you to just calculate average, means the whole reaction. You should find where the volume stops. That's your last one. Okay. Sometimes question asks for first minute. Sometimes question about second minute, means I have only specific on the second or the first one. I don't want the rest. So you have to minus off also. First 2 minutes, you will just take the whole first 2 minutes together. Okay. Yeah, there you go. That's how we look for rate of reaction. Okay, we try another question. Question number 2, which is with graph. Okay, shall we? If you have graph paper or you have printed my material out, then you have this page with you, yeah? Okay, so zinc powder in dilute hydrochloric acid, gas bubble are formed. Well, if you don't even know what is this reaction, right, that's fine. That doesn't matter, because what we're looking at is rate of reaction, how fast they react. But a little bit background for you, this is from your lower form. When zinc with acid together, it forms hydrogen gas. Yeah, hydrogen gas. Gas collected every 20 seconds, recorded every 20 seconds. That's the interval. So tables given. We have to, first question, draw the graph, line graph, to show time, volume of gas against time. Yeah, so volume of gas against time. To save time also, I already draw here for you in the picture, in the graph paper. So this one is always your y-axis, this is always your x-axis. Whatever mentioned first against the second one, that is your y versus x. Okay, if you want to learn a very basic step-to-step how to draw a graph, you can click the link above. That will bring you to the video. But for now, let's just assume we have done drawing the scale. Okay, well, the scale given here, the smallest for time is 20, the largest is 180. Hence, this is my scale, 40, 40, 40, 40, 40, 40. Okay, and for volume of gas, the smallest is 0, the largest is 22. I guess I can go for 5 all the way to 25. Try to use the graph paper as much as you can. Do not draw a small one at the corner, like very cute like that. It's not cute at all, okay? Just use the whole graph paper. Yeah? Okay, so let's draw the plotting, shall we? 28 when time is 20. Okay, 5, 6, 7, 8. 5, 6, 7, 8. Yeah, there you go. Okay, next one, 40 and 12. 40 and 12. 10, 11, 12. There you go. Okay, all right. Next one, we have 60, 15. 60, 15. Okay, next we have 80, 18. 80, 18. Okay, right. And then we have 100, 20. 100, 20. Okay, next we have 120, 21. 120, 21. Okay, and then we have 140, 22. 140, 22. 22 and 22. Am I correct? Yeah, it's all 22 at the end. Okay, there you go. That's how you plot a graph. So I already got the measurement here. I'm just gonna draw one line, straight line first, because since we already know it's a straight line. Okay, can, no problem. Okay, then we will need to join lah. So as usual, you will need to draw a smooth graph. Okay, even I might need to do a few times and not satisfied. Nah, not bad. Okay, cool. Can? Yeah, somewhere there. Alright, that's how you plot a graph lah. Yeah, I'm pretty sure you already know how lah. Okay, like next one. Calculate the average of first 40 seconds. Okay, first 40 seconds. Right, we just want to focus on the first 40 seconds. So first 40 seconds is here. Okay, that means 12 minus 0, 40 minus 0. Okay, so rate of reaction equals to 12 over 40. Lazy lah, but you can do the steps again. 12 minus 0, but it's actually okay lah like that. Yeah, so calculator will do the job. 0.3 cm3s negative 1. Okay, all good, shouldn't be a problem. Very straightforward, yeah? First 40. Next one. Average rate of reaction for the first 100 second. First 100. Okay. First 100. There you go. Okay, so 20 minus 0. 100 minus 0. So it's 20 over 100. Okay. First 100 means from the 0 to the 100. First 100. So that equals to 20 cm cubed over 100 second. Okay, calculator will do the job. 0.2 cm3s negative 1. Okay, question C. So based on the plotted graph, determine the rate of reaction at the 80th, right? This is what we call the instantaneous, or the one that we say we need to use tangent to find the answer. When you see very specific 80th, means I want spot on 80th, not 81, not 79, not the first 100, not the second second minute, not those. This is very specific on point. 它很准确跟你讲要80秒，我不要之前之后，我也不要说整个一段之类的。So this is the type where we need to use tangent to find. Okay, so on the 80th, so you should go to your graph and look at the 80th. This is the 80th that you want to hit on. Okay, first thing first, I need a ruler lah. You use a longer ruler, then it's easier lor. So what you want to do is, let me just draw okay, so what you're looking at now, the blue color line represents my ruler. I mean, I can't show you ruler right now. So I want to place my ruler near the 80. I want to draw like a straight line so I could hit the 80 like that. Like this point is touching. So you can draw as long as you want. Actually doesn't matter when you can draw over the whole graph also can. As long as you can find like a point where it touches or is just on point of 80. So this takes some time to practice and also to adjust, draw a few times. Make sure you use your pencil to draw lah. Okay, so let's say I draw a straight line lah. Now I want to find 2 points from here and there, the top and the bottom, to get the coordinate. So I can use the tangent way of looking for your answer. So I draw already. Now I'm going to look for some point that are comfortable. Let's say you don't want to look for points like that that doesn't hit on like 它没有动到你要讲这个是什么号码很难耶。So you might want to get points like that. This is hitting on. I think this is even better because I got number 120. I got number, yeah. So I think that is a lot easier. I'm going to take this as my example. Okay, let's get another line, another plotting here. I like to get the one that I had lah. So I get, let's say I get here lah 40. Okay, 40 and okay, never mind. We will write down the coordinate for now. So this is, what is this? 40. What is this? 11, 12, 13.5. Yeah, 13.5. Okay, cool. Right, this is my x1, y1. Yeah, okay. Like next, we need to find out the plotting for this side. So this side is 120. Okay, versus what is this? 21, 22, 23, 22.5. Okay, 22.5. Okay, cool. This is my x2, y2. Okay, we will use the gradient way to find out. Yeah, that we have just draw one line. It's called tangent. Now we will look for the formula, which is y2 minus y1 over or divide x2 minus x1. Okay, then we'll be able to find that particular point, the gradient. Yeah. Okay, let's get to the question. There you go. So r equals to y2 minus y1 over x2 minus x1. Okay, so my y2 is 22.5, y1 is 13.5. 22.5 minus 13.5. By the way, that's my cm cube. Okay, over x2 minus x1, 120 minus 40. 120 minus 40. Okay, calculator will do the job. So 22.5 minus 13.5. 9. 0.112, 3 decimal maximum, 0.112. Okay, now if you have tried drawing and then you got all the numbers and then your answer is way different from it, doesn't matter. You know why? Because wait, I forgot about the unit. Because question or answer are looking for any answer plus minus 0.1. You know what's the meaning of plus minus 0.1? Means your answer could be 0.212 or 0.012. That's a very big gap. Like no matter how you also correct one. You jinsai do also you correct one actually. The gap is quite big. So very low chance that you will get a wrong answer as long as you are in the range of plus minus 0.1. Then that should be acceptable already from your marking scheme. Okay, so I have one more question for you to try out on your own. The same idea. Don't worry about what is happening. Just go with what question wants, which is the rate of reaction. But you have to draw the graph on your own without me preparing it for you. So you have your own graph paper. Make sure you draw the same thing. Volume of gas against time. So that is your y-axis against your x-axis. You have to create your own scale. You have to see properly. Don't simply create scale. Okay. As I mentioned, if you really need to learn from basic how to draw a graph and how to make scale, you can go ahead and watch the video in the link provided. But for now, please make sure you know how to form your scale properly. Okay, and please make sure you write down your title, and then plot your graph and draw as usual. The last one usually straight line one, just draw with ruler, and the rest you freehand till you touch 0. Yeah, okay, and then go on with your calculation, I guess. And there you go. This is the instantaneous 90th second. Means I want to find the gradient spot on 90th second. So do the tangent method and look up for your coordinates like this one. Okay, you try lah. Belum try, belum tahu lah. You try on your own. Answers are actually provided behind the material, so you might want to download the material, help yourself print it out, and practice one time on this question. So this is how you tackle question for rate of reaction. Well, I hope the video is helping. So if you like my video, give me a thumbs up, subscribe, maybe share to your friends. I will see you in the next one. Bye guys.